All right, guys, sorry for the delay. We're going to go through the review sheet number 2 here. Um, so just a quick review, law of sines. Remember, for law of sines, you need two sides and two angles, and they have to be across from each other. So we can do sine of A over A, or A over sine of A, B over the sine of B, or sine of B over B. And okay, let's get focused. Okay, or we can do C over the sine of C. And remember, the letters are arbitrary, so if it's D, you can use D, it doesn't matter. So for the first example, we know AB is 10, so make sure you label this on your figures. Angle B is 20, angle C is 30, and I'm looking for B to the nearest tenth. So since I'm looking for B, I'm definitely going to use sine of B over B. And the other one I need two of. I need a pair of angles inside that I have, which would be C. So sine of C over side C. And then I'm just going to cross multiply. I'm going to plug in. So sine of B, which is 20, over B, is equal to sine of C, which is 30 over 10. So then 10 sine 20 is equal to B times the sine of 30. We divide out by the sine of 30. And we're going to get B is equal to, and this comes out to be 6.8. All right, cofunctions. Remember, if the sine of A is equal to cosine of B, this only happens when we do sine and cosine. Remember, we talked about this in right triangles. So if A and B are the two acute angles, then we know the measure of angle A plus the measure of angle B is equal to 90. And the vice versa. If we know the angles at the 90 already, okay, that means we have a right triangle. All right. And then we know the cosine of A is equal to the sine of B, right? And also we know that the sine of A is equal to the cosine of B. So for the two functions they're going to give you, they're either going to tell you you're taking the sine of this angle and the cosine of the angle, or they're going to tell you what sine and cosine are equal to. So if you have the sine of the angle, then you just add the angles together to equal 90. Okay. Plus 50 equals 90. And then we solve. So you get 4x plus 50 is equal to 90. 4x is equal to 40. And x is equal to 10. Mind the groaning kid over there. And the second one, we know that these are equal to. Okay, so in this case, we just want to say that this is equal to this. Remember, the sine of A is what it's equal to is equal to the cosine of B. So here, we have the cosine of the angle, and here we have what sine and cosine. Okay, so we know the sine of A is equal to the cosine of B. So here we have the values of sine and cosine versus the angle measurements. So we're just going to do x plus 10 is equal to 2x minus 30, and then we can solve. So we're basically going to subtract x and add 30 to both sides. And we'll get x is equal to 40. Okay. For the last one, for SOHCAHTOA, remember we're going to use the inverse function. So the trig button on the calculator and the inverse function. So remember, find your angle, label your sides, you have adjacent and hypotenuse. So we're going to do the cosine of A, and then you do your ratio, and then you're going to do your cosine inverses, okay? And in this case, this is going to work out to be 49.5. All right. Number one, okay, so remember, if we have a triangle, you're going to ask yourself, what type of triangle do I have? All right, so if it's a right triangle, Pythagorean theorem, SOHCAHTOA, you can use law of sines as well. And if it's not a right triangle, okay, this should be the measure of the angle. I don't know why there's R's there. Then you're going to, if it's not a right triangle, you can only use law of sines and cosines. So law of sines, remember, two sides and two angles. So I'm looking for RT, which is this side, which is S. So I don't have three sides and an angle. So that's law of cosines. So I have to use law of sines. So I need to figure out this angle first. So I'm going to add these two together to get 145. 180 minus 145 is 35. And then I can do the law of sines. So the sine, and here we're going to definitely use S because we're looking for side S. And I always just put the sine on top. It's just habit. And the formula up above. as the side on top. So it's just whatever you choose or plug in. So sine of 35 over, I don't know, is the sine of 105 over 30. We just cross multiply. So s times the sine of 105 is equal to 30 times the sine of 35. We divide by the sine of 105. And we get s is equal to 17.81. Okay. For the next, we're going to find length of TS, which is r. So we could use law of cosines here, but the easier way is to stick with the law of sines. So we're going to do sine of r over r equals to sine of t over t, and then sine of 40 over r is equal to the sine of 105 over 30. Cross multiply again. 30 sine 40 r times the sine of 105. Divide out again by the sine of 105. And we're going to get r is equal to 19.964. All right, on page 2. I'll send you guys these 2 pages first, and I'll finish up the other 2 so you guys can get a start. Okay, so number 2, we have a right triangle. You have only side lengths. So remember, if you're going to do SOHCAHTOA, sure, Kate. Hi. You're upside down now. Go on. You have to have 2 sides and 1 angle. All right. If we're doing a squared plus b squared equals c squared, this is all sides, no angles. All right. So since we have all side lengths, I can use that. So remember, we have a squared plus b squared is equal to c squared. So we're going to plug in. So 9 squared plus 12 squared is equal to c squared. This is equal to 225. And then we take the square root, we get 15. Remember, there's another formula you use here, which is c squared minus b squared is equal to a squared. So 10 squared minus 6 squared. This is equal to 64. And then when we take the square root, we're going to get b. All right. In number 3, be careful when you're doing radicals. Remember that when you're doing a radical, when you use the Pythagorean theorem, you need to use parentheses, okay? So here we have, call this a. So we have c, we have b, we have a. So we can do c squared minus b squared is equal to a squared if you'd like. Okay, so 2 radical 15 squared minus 5 radical 2 squared. And then this is 2 squared, which is 4, times 15 squared, which is 15. 4 times 15 is 60. 5 squared is 25. 2 squared is 2. So that's 50. Just, you know, if you went in doubt, use your calculator here, okay? So just plug that in. We're subtract, we're going to get 10. And then the square root of 10 is equal to a. All right. Find the exact value. So that means we're going to use SOHCAHTOA. We're not going to use SOHCAHTOA. Exact value. We're going to use our special right triangles. So tomorrow I'm going to give you guys the drawing of it with everything labeled. So when we're in the 30, 60, 90, we always start across from 30. We call that x. The hypotenuse is 2 times that. And the longer leg is x times radical 3. So if this is x, this is 2x. So if 2x is 100, then x is just 50. And if we needed it, this would be 50 times radical 3. Okay, 45, 45, 90. The formula for that, once again, or the pattern for that, is we have the 2 legs, which are x, and then x radical 2 for the sides, for the hypotenuse. So if this is 10, then this is just going to be 10 radical 2. All right. For number 5, determine the side lengths below to create an acute obtuse or right triangle. show calculations and an inequality just by your answer or an equation. So remember, in a acute triangle, okay, the a squared plus b squared side is bigger than c squared. All right, in an obtuse triangle, the c squared side is bigger than the a squared plus b squared side. And in a right triangle, the a squared plus b squared side is equal to the c squared side. Okay, so if we try the first one, remember c always is the largest number, okay, and a and b are the other ones. So we want to check what's 7 squared plus 8 squared, okay? So you can just take your calculator. 7 squared plus 8 squared is 113, okay? We know 9 squared is 81, and then we can say that this is definitely acute, okay? And the reason is that a squared plus b squared is greater than c squared, okay? The second one, now the other option it says this. So if we do 7 squared plus 8 squared, that's bigger than 9 squared. So that would be our inequality, so to speak. Okay, and the second one we have c is 16. So 16 squared is 256. And then 10 squared plus 12 squared is 144 plus 100, so 244. And then we can see that 16 squared is bigger than 10 squared plus 12 squared, so this is obtuse. All right, and the last one here on the second page, in triangle ABC, and side A is equal to 6, so we want to draw a picture. All right, good job. So in this one, this is not a right triangle, it's actually acute. We have angle C is 60 degrees, angle B is 80 degrees, and A is the one that's left over. So if we add these two together, it's 140. 180 minus 140 is 40 degrees. We're looking for side C, so that's over here. We have side A, which is 6, and so now I can do law of sines because I have two sides and two angles. Okay, can't do SOHCAHTOA, Pythagorean theorem, it's not a right triangle. So we're going to do the sine. We're using A, okay, so we're trying to find C, so we're definitely using C. And then we're going to use A because that's the side and angle that we have both of. All right, so when we plug in, we're going to do the sine of C, which is 60 over C, and then the sine of 40 over 6. So we get 6 times the sine of 60 is equal to C times the sine of 40, and then we just divide by the sine of 40. So, we'll take your calculator, we can do 6 trig sine 60 over trig sine 40. Okay, 6 sine 60, 6 sine 40, and we get 8.08. It says nearest integer, so C would equal 8. And if it's got units, those units down. All right, I'm going to post a video. I'll do 3 and 4 in a second.